Now, in the other videos that we've done, other problems that we've looked at, we've talked about adding and subtracting where you have to have like radicals. Like radicals, of course, have same index, same radicand. We've talked about multiplying, and when you multiply, they have to have the same what? Nope. They have to have the same index when you multiply.
Oh.
Right? You multiply square roots with square roots, cube roots with cube roots, and if they're not the same, there's a long, drawn-up process that we have to go through to get to them having the same radicand, having the same index.
Around multiplying, not being picky.
Yeah, that was like unreasonable.
You know, sometimes that
That was progressive.
they can still multiply, but sometimes it's difficult, right? You know how that is. They may not be exactly the same. They can get together, but things are a little bit more complicated when they do. Now, division. I don't want to have expressions with radicals in the denominator, so we're going to talk about rationalizing denominators, which is rewriting so that I don't have a radical in the denominator. You with me on this?
Yes.
Now, this can be difficult to explain, but easy to understand. Watch this. I need to multiply this times something that will complete my square root. If I look at this guy right here, okay, we're just going to draw this little picture. How many of the same factor do you need to have a perfect square? You need to have two of those, right? Now, right now, I have A3, right? What would he be missing here to make this a perfect square?
3.
He's missing a factor of 3, right? Now, what I can do is I can put that factor of 3 here inside that square root, because now they've got the same index. But if I put the 3 here, I also have to put it up here, right? So basically, I'm multiplying this guy times what? 1. Multiplying times 1 is a legitimate operation when I'm working with fractions to give me an equivalent expression, right? Now watch what happens. In the numerator, I get 1 times the square root of 3, which is just the square root of 3. But look what happens in your denominator. What does that give me, really? It gives me the square root of 9, which is just what? It's just 3. So I was able to rewrite my expression without a radical in the denominator. Do you all agree? Now, this right here is a perfectly acceptable answer. And one of the reasons we like to write it this way is so that we can rewrite it like this. You can also say that that is 1/3 the square root of 3. Okay. It gives us a deeper understanding of how many square roots of 3 we have. We've got 1/3 of a square root of 3. And some of you may say, wait, how did you get that? That doesn't make any sense. What if I wrote this? If I have x over 3, how would I rewrite that so I could clearly see the coefficient?
1/3 x.
I would have written that as 1/3 x. Okay. Now, either this way or that way is fine. It doesn't matter. Is that okay? Let's do some more examples so you can see what's going on here. Remember, at any time, feel free to pause the videos. I don't know if you guys realize that you can do that, but you only pause it when somebody's coming in and we're supposed to be working. And so you pause it and you go to something else so you don't lose your spot. That reminds me, there used to be like a work mode when Tetris was first introduced back in the 80s. They'd bring up a picture that looked like a spreadsheet, so it looked like you were actually working when the boss came in. It's called the boss button. Not that there's a boss level on Tetris, but anyway. Now, if I've got 2 square roots of 7, you don't have to do this, but sometimes it'll help you out. I'm dealing with the square root, so I need to have 2 of the same factor, right? I have 1 factor of 7. What am I missing?
7.
I'm missing another factor of 7. So what do I multiply the top and bottom by to rationalize? The square root of 7, right? So in this denominator, I've got the square root of 7 times the square root of 7, which is what? The square root of 49, which of course just equals 7. I think you kind of knew that it was going to be 7 anyway, because you're creating a perfect square with a 7, with 7 squared inside that radicand. So my denominator is 7. What's my numerator?
2 squared root of 7.
It's 2 square roots of 7. So you can write it like that, or how else can you write that?
Would be 2 sevenths. So,
2 sevenths square root of 7, right? So again, I don't really care which way you write that. Is that okay? Well,
Just
It's very deep subject.
question, Doug?
You said, well, also it's a very deep subject. For such a shallow.
If I have 10 over the square root of x, what factor is missing here?
Square root of x.
I'm just missing the square root of x, right? Because this denominator would give me the square root of what?
X.
No. It would give you the square root of x squared. And then what does the square root of x squared equal?
X.
Now, remember, we're saying that our variables represent non-negative powers now. So I'm going to get just x. So what does this guy equal now?
10 square roots of x.
10 square roots of x all over x. What do you think?
fairly simple.
It should be, as long as we pay attention to what we're doing. If you look back at what we have here, we're trying to get a perfect square. We already have one factor of x, and what were we missing? We were missing the other factor of x, and that's what we put in, right? Is that clear enough?
Mm-hmm.
Some of you are nodding and kind of half smiling. You're afraid of saying that this is good for fear that I'm going to make things difficult.
Possibly.
All right, how about 6 over the square root of 2? Now remember, you're right here next to the microphone.
You said darn it.
Darn. Oop. I didn't make a reference. Just thinking it. So what is this guy missing?
Square root of 2.
He's missing the. So these are getting to be too easy, right?
No. You're getting too hard.
So what do I have in the numerator?
6 square roots of 2.
6 square roots of 2 over what?
2.
4.
Over 2, because we know that this stuff is going to give me the square root of 4 when I multiply that, which just equals 2, right?
Is it always pretty much going to be the denominator?
I'm glad you asked that question. We're going to see that in the next example.
So now
Actually, we'll see that in the next video. Got to keep you coming back for more. But-
it's 3 square roots of 2.
Right, so when I reduce this, I get 3 square roots of 2. So, is it always that we're multiplying times what we see in the denominator? Find out on the next exciting installment of Simplifying Radical Expressions.